So another little car talk video. I'm reading this book, Measurement. Story of Measurement. Got it from the public library. It's been on my mind for a while, and of course, what happens with theory development is you don't have it all at the same time. You just get a little bit and a little bit and a little bit, and then maybe a month passes, 3 months passes, then you're, oh, that's where those fit together. Right now, what just happened to me, the half-lives, radioactivity, and isotopes. This little graph right here, or table I should say, the isotope half-life of U-238 is 4.46 times 10 to the 9, 4.46 billion years. So the half-life of uranium is about the same age as the Earth. Maybe that's a coincidence, maybe not, who knows? We'll have to do a little bit more research into that, but I find that to be pretty interesting, being that they discovered the age of the Earth. And, well, they actually didn't discover the age of the Earth, they discovered the age of iron-nickel meteorites, which don't have a lot of uranium in them, to be honest. So what we have here is some detective work to do. How exactly did they determine that meteorites were 4.45 or 4.46 billion years? Did they assume that? We're going to have to do some more digging, because that's maybe a big portion of the dogma that needs to be uprooted. Because from what I've seen, the objects in the solar system can be vastly older than 4.45 billion years, which means if we're going to radiometrically date them, we need objects, or we need isotopes more or less, that have half-lives in the trillions of years. So it would be 1 times 10 to the 12. Mercury, if it had an isotope that matched its total age. Now, this is all hypothetical, but I based Mercury's age off its total axial angular momentum of 32.75 trillion. So Mercury's, or the isotope that Mercury would need would be, let's see, 3.275 times 10 to the 13. And I'm looking on this little graph here. We find one, tellurium 123. So that's about 1.3 times 10 to the 13. So if we can find enough tellurium in Mercury's crust, we can radiometrically date Mercury using this theory. Now, tellurium, I think, isn't one of the lanthanides. It might be one of the lanthanides, I'm not sure. Or the other one, the rare earth metals, it might be one of those. And those are really hard to separate. So I see some challenges with that. As well, we can go completely through the roof with vanadium, vanadium 50. That's half-life is 3.9 times 10 to the 17. I don't think we're going to need to go into the quintillions of years, but we can if we want. And that's where this theory is leading us. We can determine the ages of these objects outside the bounds of the atomic age, where they took major assumptions and they made them true, and then built on top of those assumptions into oblivion, from my perspective, because they don't actually understand what happens to stars as they evolve, and they don't actually understand what the Earth is. As well, the krypton hypothesis, I don't know if you guys remember reading about this, the little paper I wrote, is essentially the objects that we find, the objects that are smashed up remains of stars, meteorites, chondrites, iron-nickel meteorites, basically all space dust, if you think about it. Those are remains of ancient dead stars that have been smashed to smithereens and could have possibly had life on them, just like Superman's home planet Krypton did. This is why called it the Krypton hypothesis, and that those pieces of those ancient dead stars are raining down into the atmospheres of much younger stars, which means those meteorites could have come from somewhere else in the galaxy, all completely outside of the solar system. But the dogma has it to where all this material forms from the leftover remains of the sun, which I think is totally absurd, because clearly that's what it is. It's star shrapnel that came from somewhere else. We have a method now to take the isotopes that have much higher half-lives, and of course I'll write a paper. I didn't write a paper on this yet, I just thought of it, and so I decided to make a quick video. That we can take these isotopes and figure out how old these objects are using a completely new worldview, far outside of the nuclear age, where they were highly conformist. NASA was a very conformist organization. Everybody was bashed into place, you know, the saying, the nail that sticks out gets hammered. So they made it to where everybody conforms and everybody gets along, and, you know, but we don't have to do that these days. We can question the ideas they have. Of course, people are doing that, but in reverse in some cases, like they go after flat Earth and we never landed on the moon. Of course, it's good to question, but I don't see questioning those things. You should question the science behind a lot of the claims. That's where the real treasure is. Don't go looking at conspiracy stuff. That's a waste of time. There's always going to be enough people to do that. If you really want to get to the meat and potatoes, the real amazing stuff, the stuff that really brings in-depth understanding of the world around you, don't go in reverse, go forward. Question the assumptions a scientists make about the world around them, where they didn't have enough information to make a real assessment of what they're looking at. Now that we're moving into the 21st century and we have exoplanet data and we have orbiters that actually have orbited Mercury, we didn't even have an orbital spacecraft around Mercury. The Messenger, we didn't even have that. And they had already accepted how Mercury formed. They didn't even have they didn't even know what the surface looked like for the most part. Yet scientists had accepted how it formed, and they still teach that it formed from the leftover remains of the sun. There's no way that thing is related to the sun. It's a very, very old star. So our next step in science is going to have to be using isotopes that have much more extended half-lives other than U-238, as was popular during the nuclear age, when we were, developing nuclear bombs, and we dropped 2 of them on Japan, and we were really going ape shit with that stuff. And we sort of calmed down, and that's a good thing, because now we can take that sort of weird paranoid warlike mentality and we can just put it on the back burner and actually look at the science behind radioactivity and actually apply new concepts to the observations that we're making, rather than accept the people who invented all this stuff as being true without questioning it. All right, you guys, I just want to make that quick talk and look up the half-lives of these things. There are elements out there with insane half-lives where it's just like, what? How did they figure this stuff out? I'm not too sure. I'm going to go ahead and look up a lot of this as well and learn about it as much as I can. All right, later, y'all. Oh, today is, what is today? September 5th, 2019.